Okay, today we're going to talk about areas of polygons specifically, so a little more than just your circle, your triangle, perhaps your rectangle square. We're going to look at hexagons, octagons, a lot of different polygons here. So we have a new formula and a few new vocabulary words as well. So just to recall though, before we get started, we're going to look at what is called that regular polygon again. Think of the word regular. What does it mean? Okay, regular polygon means that our polygons are equal angular and equilateral. So all sides of equal length and all interior angles of equal measure. And that would be length of sides and measure of angles in degrees. Another word to recall would be our central angle. Central meaning the center. So the vertex is at the center of our polygon. So we'll see the central angle marked here. All right, so a central angle of a regular polygon has its vertex at the center, and its sides pass through the consecutive vertices. So consecutive meaning one right after another. And then the sum of those measures of all that central angle measure will be the 360 degrees. So just a little bit of review there. We see also that the center of our regular polygon is equidistant from the vertices. So from the center to the vertice, which is that point, is equidistant from, first example, the center to this vertex, and from the center to this vertex, and so on. So the center equidistant from each of those vertices. So now let's get into a new vocabulary word, and it is called the apothem. The apothem is going to be the distance from the center to a side. So on this diagram here, from the center down to a side, and you'll see that that's actually also perpendicular to that side. So the area of a regular polygon with apothem A and perimeter P is going to be this formula right here. Area equals 1/2 the apothem perimeter. So for example, each side of a regular hexagon is 10 meters. The apothem is 5√3 meters. Find the area. Our first step, we will find the perimeter. Remember, perimeter is the distance around. So we'll take the perimeter is going to be equal to 6 times 10, which is 60 meters. Where did we get this 6 here? Well, recall that our shape is a hexagon. So hexagon has 6 sides. 6 times 10 is our 60. Then we'll just simply substitute into the formula. So we have 1/2, 5√3 times 60, and that's approximately 259.8 meters squared for our area of that hexagon. So let's move on to a few other examples. For these first few questions here, 1, 2, and 3, you will answer those on your own for homework. But let's do number 4 together as an example in our notes. So we will use the formula for area of a regular polygon and find the area of each figure, round to the nearest tenth if necessary. So let's take a look at this one here. So I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So that's going to be an octagon. So first, let's recall our formula. Area equals 1/2 A times P. And since we have an octagon, let's find our perimeter first step. So we will take our perimeter is equal to 12 times 8. 12 is the side length, 8 is our number of sides, and that will be equal to 96. For our next step, let's go back to our area formula and let's just substitute in. So if we substitute, we end up with area is equal to 1/2, 6√3, which if you'll see here, this is our apothem. Maybe I make a little note. This is A. And then times 96, which is our perimeter, just substituting in directly for the formula. Our next step, let's simplify. So I end up with 288 times the square root of 3. And then for my final answer, let's round to the nearest tenth. I have area is equal to approximately 498.8 centimeters squared. So again, the area of a polygon, we have a new formula. This formula can be found on your formula chart. So it will be one of those given to you for the end of course exam. Why don't you try number 5 for homework, and we'll see you next time.